This is video 2, covering magnitude of earthquakes and earthquakes in New Zealand. This video covers the last details of section 1 of the report. We are looking at what magnitude is, which is measuring the energy that is released by earthquakes, giving it a value, a way to compare different earthquakes around the world. And we'll also look at New Zealand and why we have so many earthquakes. In the picture, it shows how New Zealand has a lot of basically faults on it. Faults were mentioned in the last video, looking at cracks in the Earth's crust or in the ground below us. And New Zealand is specifically at the border of two what we call tectonic plates, two big chunks of ground right up against each other. So along that border are lots of faults, and you can see on these red lines here lots of little cracks and faults in the ground. These are the places where earthquakes usually occur. These are the bits where the ground is building up pressure and then moving, releasing lots of energy through the ground and vibrating the earth. Now the arrows here show the direction that these plates are moving, where they're pushing against each other. And this one here specifically shows how we're looking at occasionally new faults being formed, faults that were dormant or there but asleep and not moved for so long that we didn't even notice they existed. So these dormant faults occur in places like here in Christchurch. There's also the one recently in news that has been discovered under Wellington that shouldn't be too surprising. There's already big fault lines running near Wellington, but one running through the city. And if in your report you get an earthquake where it has a dormant fault, feel free to mention that because that's relevant information. Also later on we'll talk about the two plates, the Australian and Pacific, which makes up the two sections of New Zealand. Measuring earthquakes, how do we measure them? This image shows hopefully a familiar picture. During an earthquake, they usually have these pens on these things called seismographs, which are just hovering and running a line. Then as the earth shakes, the pen shakes up and down in proportion to how much the ground is being shaken. And this lets us know how big the earthquake is, how intense, how much energy was released, and it can also be used along with other seismographs to tell how far away the earthquake happened. So it's used along with telling how big the earthquake was, helps with finding the epicenter, which is that spot on the ground where the earthquake started. And that lets us know the focus, how deep underground as well the earthquake occurred. So, how do we measure earthquakes? We measure how much energy has been released, and that's the key thing here. This is given a value, and the value is measured or put onto the Richter scale. Okay, the Richter scale measures the energy released by an earthquake, and it tells us in a way that we can compare them. Now you hopefully would have heard of the Richter scale before and know some of the numbers. The numbers are usually between 0 and 10. The bigger the number, the more energy that's been released. Down here's some examples. The highest ones recorded are about on the higher scale of 9, over 9. Very, very rare. The Boxing Day tsunami in 2004 in Sumatra is one of the biggest ones, 9.1. Great damage, major damage, and it's felt sometimes across the world, but the damage and destruction occurs for hundreds of kilometers, especially if a tsunami is involved. As you go down, the damage is still very serious, around 8 and 7, but it's felt still over a large area, just not everywhere. The effects are still looking when you get down to 7 or even to 6. The damage can still be affected for about 100 kilometers, a huge area. As you get down even lower and lower, the effects get smaller as well. When you get under 5, you can feel the earthquakes, but they very rarely cause any damage, just tiny bits of shaking. Anything below 4 is not usually felt. It's just a bit too little. Now these ones happen quite often, in fact all the time, but they're so small we don't feel them. It's just little bits of pressure relieving on the ground. Now, With the Richter scale, it's also important to note for the earthquake energy, the difference between each number. So we start at 1 at the top. This is very small. As you go from 1 to 2, the number goes up 1. Each time you go up a number, the amount of energy that's felt is 10 times stronger. The amount of energy released is 10 times more. So if you go from 1 to 2, that's 10 times more energy. If you go from 1 to 3, 10 times 10, that's 100 times the energy that's been released. If you went, for example, from 1 all the way up to 6, timesing by 10 every time you went up a number, from 1 to 6 is 1 million times more energy that's been released. That's a lot. So also, this relates to us, gives us an idea of the damage that's going to be caused. The higher the number, the more energy that's being released, and the movement that's made through the ground from all that vibration, all that energy, gets bigger and bigger. Okay, so 10 times more energy, for example, from 4 to 5, is where you go from a moderate amount of movement to a really strong movement. And as you get even more, that gets severe. Okay, so more energy, more movement, and that's going to cause a lot of damage. How often do these things occur? Well, the smallest ones occur daily, and these are the ones we don't feel, not usually. So when you get up to 5 or 6, every month, or roughly monthly, you'll get bigger earthquakes. And again, usually a lot of the time it's happening in the ocean, underground, or they're really deep. You don't normally feel them when it's very small. Of course, we're talking around the world, so that monthly isn't necessarily in New Zealand. But the big earthquakes, they do happen quite often. The 10s are very, very rare. But around where people are, can feel the biggest ones every 50 to 300 years, depending on where you are in the world and where people are as well. A rather than the Richter scale is called the Mercalli scale. Now this one is based entirely off people's observations. So people who are involved in it rate how they felt and what they saw, and then this is given an initial sort of intensity scale. This is often used for example, before we have the readings of the Richter scale and want an idea of how big the earthquake was. Again, not used, and you don't really need to mention it in your report, but it's good to know about because it does pop up inside the research. So all the numbers, again from 1 to 12, it goes up. And for example, a level 9 on the Mercalli scale is where you see buildings being shifted off their foundations. Okay, so you're seeing buildings starting to move, not just shake, but the actual foundation in the ground is moving as well. Alright, so taking all this information on earthquakes, how does this apply to our own country? So on the left side of New Zealand we have one big plate of land. On the right we have another. They have names, the Australian and Pacific plates. Now what's happening? These two plates are pushing against each other. Okay, building up that pressure. And there's a very specific way they're pushing. For example, here down the South Island, and where the sea is, the bit of earth is being pushed underneath, what we call subducted. Okay, it's heavier, so it gets pushed underneath, and the top is getting sort of pushed upwards. Now, very, very slowly, we're pushing against each other, building up that pressure, that energy, and then suddenly, movement. And hopefully now you know that movement and all the energy that's released causes an earthquake. This doesn't just happen along the one fault here, there's lots of little cracks and other faults where you get other earthquakes as well. Including here on the infographic the Christchurch earthquake, which was a possibly new fault line or a dormant fault line. A bit hard to know, but it's got some information about the two earthquakes that happened there. Another interesting thing, the big one across the South Island is called the Alpine Fault, and what happens is when this bit here on the right gets pushed upwards, every time it gets pushed upwards it makes the Alps, it actually pushes them and creates mountains. Okay, so that happens over many, many thousands of years, and the Alps are getting taller, just by a couple centimetres every few years or so, nothing noticeable. In the North Island, the same thing happens in the other direction. We've got the heavy ocean being pushed under, and then you've got the other side being pushed up. This along here happens in the ocean. It causes a giant trench in the ocean called the Kermadec Trench. That is pretty much an example of how the faults work in New Zealand. We have lots of earthquakes that we can talk about, lots of examples, and there are some older earthquakes, newer earthquakes. Basically, New Zealand is full of them, and some of them potentially could be in your report. It is good to know about New Zealand though, because it is a big wealth of information. So what you need to do is for section 1 of your report, so far you've been talking about the fault line, the energy stored and released, information about where it happened, where was the epicenter, how deep was it, so how far down was the focus, and now you should be able to add in some information. What magnitude was the earthquake, and what does that magnitude number mean?